controls. You have a TBM benchmark. It's important to protect it. In the case of a construction site, why is it important to protect it? Can someone give me a very funny statement about why we need to protect it?
So what's your reference point? If anything goes wrong, that's where you can start everything. But if it is not there, it means you have to go start everything over.
Yeah. You have nothing to check against. Very important. And it's very important to also name them. You see, I even started putting TBM 1, 2 when I was doing. So give them unique names that you can easily find. Reference them. Are you okay? All right. Very important. So accuracy of leveling, if you want an accuracy of 0.01 meters, right? But what does it mean? 0.01. What is that? What does that mean to you? We talk about the accuracy of leveling. So when we say the accuracy of the leveling that you're doing, should be within 0.01 meter. What are we saying? What is zero? You see, it bounds on statistics, guys. Okay, some questions don't joke with it. Play with it, eh? Accuracy. It's got to do with the true value. Are you okay? The true value, the best way all of us can get to it is through the mean. Mean. Okay? The mean. Okay? So the more, sometimes you do more measurements just to improve on how accurate. But really, we know that for every work, you need to start with the known to known, but you wish you had an existing known point to check against. And should you ever do that, that will pinch on your accuracy. I will get that. But for most engineering works,
so that is why we do after you do foresight and backside, do fly.
Exactly. You go back to where you started from.
Fly back, yes, you do fly back.
Exactly.
Check.
Exactly. Those checks are very important. Are you okay? 0.01 is of a meter is how many centimeters? 10 cm.
0 point.
In some projects, that's like cross error.
10 cm.
Okay, multiply this by service meters to get to millimeters times 1,000. 1, 2, 3. So you get you two. Did you check it well? 2, from meters to millimeters divided by 1,000. You multiply each other.
That you said cm.
Yes, from meters to millimeters, you multiply by 1,000.
Yes.
So 0.01 meters in millimeters is actually 10 millimeters, isn't it?
Yes.
Hey, you scared us. Because that would have been so up, isn't it? Okay. All right, so yeah.
10 millimeters is also something. Sorry.
It's big.
It's very big because
10 millimeters is big.
we can, let's say if you're doing filling.
That's enough. Yes. So you can end up with a project and then things don't fit anymore. Some of the issues we have in our houses, because we have people who are just not qualified and they think they can just put anything up. My brother comes to my kitchen every time and he has to do this. I think he's bowing to someone in the kitchen. I don't even know. No, I'm being serious here. That's bad engineering, right? So don't sit here and think that you're going to get yourself embarrassed. Do the right thing. That's why engineers are like soldiers, isn't it?
Yes.
That this is a soldiers to be there somewhere.
And so you build in a what's the name? Waterlogged area, but water will find its access to your room. And you think it's normal.
You see,
because we know that even water in its normal stages and above the mean sea level, 450 mm water cannot rise up to that level. And that place is water. So why don't you do that?
Exactly. So there are practical considerations for all these things. And to be shocked that it's not the exam that's going to make you a great engineer. It's not the exam. It's the piece of advice that or things that are shared in the lecture. That's what's going to make you a successful person.
I've seen it. Typical magazine where I live and where I work. They've done the cutting, cuts, but the photos that they raise, they've made it with the level of the cuts.
You can see that it doesn't even.
So I was asking myself, I didn't do any drain to.
It didn't make sense to you.
To take away the water, because directly when it means that rainfall,
it's just going to destroy everything. Water destroys most of these structures. Water can destroy them in a matter of.
Water is the strongest side.
Yes. Yes, for most engineering works.
After that is soil or sand.
Exactly. So it's very important that you take some of these things seriously. Not even for a lecture, but for your own life. Even if you go and work in a bank as an engineer, you will be probably supervising all the civil works, isn't it? So wrong supervisions and all that. Okay, let me look at a few things here. It says, because CBMs are vulnerable, they must be checked by a vulnerable. If someone is vulnerable, what is it? Re-leveling, isn't it? As regular intervals. Sometimes you have to double check that it's not moved. Why? Because there are earth movement equipment where you are. And sometimes you have some equipment there, when you start the foundations and they are hitting it. Exactly. Compactors and there's a pylon, there's this thing that you push down into the bedrock. Is it piles?
Pylon foundations.
Exactly. You see that? So if all that movement is going on the side, then things move, isn't it?
And even the changes in weather itself.
So,
yes. Dry season compressors.
TBM should be established on permanent point. I think we talked about that. It should be permanent. If it's a TBM. To avoid confusion, all TBM should be clearly marked. Copy of the side mark. I think it should be done so that we know that this one is 1, this is 2. Before you're aware, someone is using this coordinate for this. Hey. The whole week you'll be praying to your God. Father, be with me. Okay, guys. So let's look at side trails. Who has used a side trail? Can you tell a story of side trail? I want to check if, for example, I want to do a trench. Are you here? I want to check that the digging of the trench has been well done according to appropriate slopes. Are you here? I have the right levels. How do I do that? Is that okay? Can I set up an equipment that always someone is looking in there and checking if the digging is okay? Or can I also allow those who are working to just self-check themselves and see that, okay, we dig enough. Are you okay? So here we're not even talking about vertical control. We're talking about checking exactly the levels. Are you okay? How far we've gone. You can make use of side trails, which are just, structure. You just have wooden planks or something that you just construct. Okay? And then you establish their level. So instead of me just using my hands, let me just join it. Let's use it. So I have this trench. Okay. So is that deep? Okay. So I need to take this to a certain level. Okay. So this is the ground. All right. I can't have the surveyor here all the time. Sorry, the drawing is not looking very bad. Just try to see this in 3D. Okay. This is how deep I want to get into the trench. Okay. All right. This is the soil at the top. So I can stand here. All right. And then what do? Do I just stay here with my level instrument, or I take the level instrument to other parts of the project and use them? Okay, so that we don't waste resources, isn't it?
Yeah.
Do you get the scenario?
Yeah.
All right. So one of the things we can just have some sort of radio.
T-bar.
Exactly. I don't know what to call it. And then you actually know the height of it. You know the height expected. Then when they construct some, what do you call it?
T-bar.
A T-bar.
On top of it.
These are called the side windows. I make use of side windows. And then based on the calculation, anytime this T aligns with this one, then you know you are digging.
So it's also using it for your what the tankers have been saying.
They've been using it. Oh, okay. How?
That one is metal.
Oh,
But
okay.
it has
They go inside the tank.
no, you when you climb the tank, you open it.
Okay.
There's a mark on the neck. So you put that T-bar on it. It can tell you that
Principle.
yeah, it tells you that the level because the car will park on the
Oh,
where
okay.
it's level.
Okay.
So with that we'll call that place level B.
Very good.
Because when I was doing the construction filling station, that place is level.
Okay, of
So
course.
the car will stay for about 30 minutes. After that, you check. So every compartment, the car you see drives.
Yes.
Every compartment has 8 levels. So
Oh, really?
Yes. So you compare it.
I thought the whole thing was together like that. Oh, okay.
Like how
Okay. I'm learning something.
because it's liquid. It's
Okay.
loose.
Oh,
Yeah, so the compartment controls it.
compartments. So you want to check the level.
So when you check the level, you might know that the driver has tempered it.
But how does it apply? How do you apply this for like this?
That's why I said it has been, that level has been demarcated like centimeters, 2 centimeters. So immediately
So you hold it and you put it in.
you just put it on top of the car.
Okay.
When you are on top, it will lie on top of it.
Okay.
You dip it inside the
You dip it
Yes.
inside.
So you apply paste here, something that will show you the level of the liquid.
Okay.
So afterwards, when you finish the shading, you cannot argue with you.
I understand. If you understand where Chris is coming from, these things you don't have to be taught in school.
No.
You can learn it from childhood. If you have been sent to the farm to fetch water and some of these things, it's just common sense. You get what I'm saying? It's a common sense that it doesn't need to be taught. It's just common sense. And we don't need to do a calculation. I can challenge you all to do it. I will be teaching you. Show me how you would establish the height. We don't have to do it. Are you okay? All right, so you can actually have it slanted to at a certain angle, just to ensure that we have a certain slope. In the same way, you have to use your eyes to check if the heights conform with the slope. Are you okay? So they are like offsets. If you know your geometry, you have this. The line that's parallel to this will always offset the same distance. So if I have something
It goes with the same.
exactly. So anything that kind of flashes with this conforms to so the slope here, the slope here, then at least. It's literally common sense. Like some things in engineering are common sense. Do you know what I'm saying? All right, so side rails. Yeah, basically, I want you to read about these things. Here, what you are calling the T-bar is a traveler. Traveler. Okay. And this is a better picture of.
Yes. Yes.
A bigger picture. Okay. Yeah. Okay, so read around it. Okay. And then let's have fun. Yeah, so that's that. Okay, guys, that's it. If you have any question that is interesting, you can just ask. Otherwise, let's change topic and end on that topic. I'll just finish in the next 30 minutes. But these days, I don't teach for long. I'm a changed man. This teaching and teaching things. The students understand. They tend to even think the thing is so difficult. That's why you are taking so long. Right? Do not like. I say I'm your case. Whether you smile or not. Okay.
So there is a road at Mangasin
Okay.
giving problems to people.
What kind of problems?
It's in both horizontal and vertical case.
Okay. Naturally, you see, that is a very dangerous situation, isn't it? It seems to be ideal, but I'm thinking that once we start bringing in horizontal and vertical, which is really real life, that's what happens. And for a lot of drivers,
Even
it
this one
increases the
transportation
risk
workers, yes.
of accidents. Are you okay? All right. So this is not. Let me pause it because I think it's not really on it. Or this.
No, you said we should ask us. That's how.
Okay. Resume the recording. Okay. So GPS has come to stay for us, and we are using it in engineering application. That's why we are talking about it. Is that okay? Are they seeing the screen?
Yeah, please.
Yes. This Bluetooth, I don't even know who came out with it, but anyway, I'm still trying to figure out what the advantages are. Okay, so the GPS is made up of 3 segments. Is that okay? We have the space segment, then we have the control segment. Okay, then we have the user segment. Okay, all right. So space segment, satellite. But some of you, satellites seem to sound more like searchlights because when we were children, we still saw the difference between a star and a satellite somehow, because you could see that it was lighted up, but it wasn't twinkling. Are you okay? Because twinkle, twinkle, little star, how I wonder, oh, the satellite doesn't do that. Are you okay? It doesn't twinkle. So the space segment contains all that is out there, kilometers away, okay, built from the earth and launched through the rockets, mounted on rockets, okay, module, and then goes out there. The users are just you and I. Are you okay? You and I. We use it. If a plane takes off from an airport, heading towards another airport, then they could make use of what the GPS to just guide them in the direction that they're going. All right. So that makes up the user segment. The control segment, someone has to control all this. Are you okay? Right. You have a receiver, is that not so? All right. You have a TV set that's supposed to track, to show you something on TV, right? But there's someone sitting somewhere who's actually controlling everything that you are seeing on the TV set. That's the control segment. Is that okay? Which is actually made up of a master station, okay, and then a few other monitor stations. You have a controls. Do you have one there?
Yes, GTV, UTV.
Oh, okay. For GPS, we have a couple of monitor stations. Is that okay? And some of them are on islands. No, the world is actually made of a lot of water. Are you aware that about 70% of that is actually? So we all have to learn how to swim. Are you okay? Yeah, I'm telling you the truth. You have to learn how to swim. It's only wise for you to walk at a place like this. You don't know how to. So basically, the monitor stations are there. Okay, and then they have satellites, dishes, receivers. Are you okay? And then they send information to the master. Why are they there? They've been distributed around the earth. Okay, in such a way that the satellites are supposed to be all around the earth. And so that everywhere you are, this global can come to pass. Global means you don't give a part of the earth access to it and another part doesn't. Global, when you see the word global, means everywhere around the globe. So we should have enough satellites all around. But then to monitor them, I need to have enough monitor stations such that they can collect information and tell us about the health of the satellites and know whether they are working or not. Are you okay? All right. So the monitor stations are different from the master Master station. It's a place where we have the data and information from the satellites, okay, and then know what to do. Are you okay? Say again. Yes, so the master station is the US.
Yes, it was controlled. It was established by the US Army.
Right.
You said it's the place where you collect the data.
So the master station is making sure that these satellites are working. Let's say when I wake up in the morning, I'll go to work just to check. Are you okay? To make sure that particular satellite, Sat1, is actually okay and transmitting. Is it necessary? Why don't we go to bed? We know that it will be there for like 5 years, isn't it? Why don't you just don't build any station, right? You know, when it's about 5 years, go and build. Someone go to work every day. I've asked myself that question in Ghana that people go to work and they don't do anything. So today, if Uber can come and pick you, it's because someone is making sure that those satellites are working. Okay, so that is how it works. We have just one master station, then we have other monitor stations. Is that okay? Right. And all these things are working to make sure that these satellites are doing the right thing.
So, sir,
Yes.
I know that is US military-based established the satellites. They are the first.
That's the history of it. Yes.
Yes, but I know now China and other countries also.
They've also come out. China has a big compass. There are different ones. Europe has their own. Okay.
Okay.
Russia also have their own. Are you okay? So it's like, well, if you are powerful, let's see you also do this.
Up there.
Okay, Ghana, we are powerful. Put it there, Ghana too. Are you okay? You can see that we are not powerful, isn't it? All right, so we can't do it. Are you okay? So of course, you know the world's powers. So they all try to have a certain presence. Just because the GPS is actually founded on all its benefits and application, bounds or hinges on security.
Yes.
Why? I always think about it. I believe in it, but I don't believe it. Why should location have anything to do with security?
If your enemy wants to attack you, he looks for where you are located first before he plans how to attack
The
you.
only place where I see security is when in Prison Break, they were tracking, Schofield, Ayaki, who is actually in the movie. The good guy is called what?
Antagonist.
Very good. They had the protagonist and the antagonist. So in the end, Peter Schofield, because they kept a certain device in his pocket, they could easily see his location. So that's his security is now compromised. So he was asked to, his brother told him, throw it away, whatever the woman gave it to. I get what I'm saying. Now that thing was a GPS receiver. So for security reasons, countries have also decided that we gotta also do this. And that's also because of the proliferation of knowledge. Except Africa, where we're not interested in knowledge. Interested in fufu. This part of the YouTube, I have to go and no, but
That's the truth. That's the truth.
That's the truth.
We're interested.
Yes.
That's the truth. And that is why all the other European and American, they come to us and they bully us in any form of way. They go back.
So I encourage you guys, if you want to do your masters, do it. Probably become a specialist. It's okay. Civil engineer, specialized. For us, okay, let's finish with GPS. Okay, so basically, the user segments, the military use it. How are the military using the GPS? Think about a drone. Anybody quickly? Let's have an interesting class. We are ending the class. How would GPS combine with a drone and become a lethal weapon? Anybody else quickly?
So let me see. I can give an example.
If you had a drone right now with you as an engineer, how the GPS combine with it? This could be an example question, but I won't ask. You never know me anyway. So if you had a device It's a bomb. How do you now combine GPS? And it becomes even more lethal, extremely lethal. I'll just give you the answer, but still repeat it for me. Yes. Side. How? The engineering. This is a bomb. It doesn't need a GPS, does it? Great. Then now I ask.
It gives you the accuracy. Gives you
Okay. Let's be watching such movies.
because Osama bin Laden, they used drone to, and within 5 hours
And
from
they had
US.
they had presence locally
Yes.
as well. They were military down there. Okay, so then they could now move it, isn't it? So the accuracy. So GPS is actually a precise navigational tool for the military. In fact, they advertise the position. They say we need a specialist who is into this technology, GPS, geoscience. They will put it there. All they need is that they will drill you a bit and let you do some up and down. That's go in there and help us. Is that okay? Coordinates. From there, going, you won't do any exercise again. You'll be fine. Are you okay? Of course. Search and rescue during some sort of disaster. How does GPS come in? So if you've not been, you see, Africa is just the holiday resort. I'm sorry, this is not a political science class. But engineering has to touch on the society. Are you okay? You have to touch on the society. So we need to get emotional sometimes. Are you with me? If there were a lot of earthquakes, we start thinking.
Yes.
Because once there's an earthquake, quickly all your coordinate systems are not. All these things we talk about, horizontal control, YAML, you will think. You will start thinking even beyond. Are you with me? How do we know where was what? Because now the whole thing is mashed up. Max, are we in the same place? All right. Surveying cannot be done with the context chain anymore. Not even GPS, but later we'll talk about it. Like
Electronic system.
There can be a better system than GPS.
Electronic systems won't work.
I mean, context chain. Context chain. Who said of it? The days where engineers worked and they used a chain, literally, it was heavy. You have to be macho to be part of the team, or you need a macho man in your team to measure distance.
The initial surveying.
Everything is surveying starts with measuring distance, some sort of distance. Are you okay? Could be angular or linear. Are you okay? So distance measurement can be what? Angular or linear. Don't forget. And I'm just saying that in surveying, we can apply the GPS so that we can get what? Easily survey without pulling tapes. Yeah. So is that not a leap? One leap for what? Engineering. And another for what? Mankind. Okay, so marine. What about a marine? Going under sea, GPS may not work under the sea, but we're not talking about bathymetry here. We're just talking about you being on the sea and at least knowing where you are. Okay? And before these things were created, where a ship knows that I am definitely in the Indian Ocean. I know I'm just 20 kilometers away from the port, from this particular port. There were lots of disasters. A lot of ships disappeared because we have not charted the terrain. Are you getting that? So, surveying marine, aeronautical, what's aeronautics about? Airplanes. Mm. The Malaysian airline disappeared, and we haven't found it since 2014 or so. Are you aware? Yeah. And there are a lot of machines that were sent down there. They spent like millions of dollars and actually they couldn't even find it. I'm telling you that if this interest wasn't shown and we were left to mediocre approaches to how things should be done, nobody would have even pursued it. Because when you look at the sea and this expanse, for those of us from Kumasi and the Midlands, when we get to the sea, we are like, when do we go back to Kumasi? I get what I'm saying? Because it's so enormous to comprehend it. Are you okay? So GPS sits literally within what we call the celestial sphere, something bigger than the Earth, far bigger, so that the Earth becomes smaller and we can measure it. Are you okay?